Good morning, Sammy.
Good morning, Mohan.
Come on.
Hey, Jeff, how are you?
I'm tired. I just got back from supercompute late last night, so.
Oh, you're in Denver. Okay.
Yeah, actually, good morning, Tim. I'm not scheduling any specific topic. One topic we would like to discuss is regarding CUE and why it is done that way. One can try to understand. But if any one of you have the info, that would be good to share. Give you a problem statement, right? Before even going there, like any other open here?
No, Sammy. Go ahead.
No, go ahead, Sam.
Okay. Yeah. The problem we're trying to understand is today CUE is always above one, right?
Mm-hmm.
When we say 2, we are saying it's 50%
50%.
efficient.
Right.
When we say 4, we are saying 25%
25.
efficient.
Right.
8 means about 12.5% efficient,
Right.
right?
Right.
It's not really intuitive for people when they look at the numbers. what it means. You know, it's above 1 looks bigger, right? Trying to understand why it was designed that way.
Well, why did they originally construct PUE to be the way it is?
Yeah, in that way, right?
Oh,
See, for example, if you operate your data center probably like 5% or something very.
Well, yeah, so
the PUE will look very.
So I assume that the PUE was done that way because and I don't remember this for sure, but certainly it would have been possible in the early days of reporting that number that you could have a PUE above 2, right? You could certainly be using or wasting more than 1 watt for every watt of compute power, right? So you could have been spending 2 watts on air conditioning for every watt that you spend on computing. So I think that's why they would have done it that way, because it's a ratio. Now for the new piece, I mean, that is a measure of efficiency, right? So or I mean, it is a percentage of an absolute consumption number. So maybe it would make sense to do it as a percentage, so that higher percent would be quote more efficient. But that's a good question, and and so I think that would be the thing to ask folks is, well, you have the other numbers that are declining to be better, and this one would be an increasing to be better. But if you declared it as a percentage, then instead of giving it as a unitless value of a PUE of 1.15, like, well, my efficiency is 93% or something like that, right? So I think it's a good question to see. Number one is, do you want to change it, and is that better or worse, or is it better or worse than a 1.0 number? For the consumers of this data.
Yeah, I think the reason we are asking this question is when we are trying to define IUE, we are saying we are basically dividing compute power, I mean the total power divided by compute power.
oh my God, you're losing your network.
Power can be 0 at ideal workload, right?
Yeah.
Yeah, I think it's. I mean, that's Jeff was saying. It's you're.
Are you losing me?
Yes.
Yeah, I think we got the gist though, Sam.
Yeah, we got to just stop
I'm
it. But
switching from my parking lot to the Intel.
Network. Okay. Yeah. Once you get in, I think it'll get
better.
Yeah, I think it's just the inverse of the data center efficiencies, and my guess is that as a number, it's a number that you can optimize towards 1. And because as Jeff has rightly pointed out, maybe when they invented it, right, the numbers were well above 2 for everybody. So optimizing the number towards 1, lower is better was a lot easier than, essentially giving somebody a percentage and trying to push towards higher is better, because at some point, like where we are right now at 1.03 or something like that, you're kind of at a diminishing returns standpoint, which doesn't show, like 1.03 still is a lot more palatable discussion to have than right, whatever 99.99 whatever it would have been.
Yeah.
In some sense. Right. So like like the Intel's data center is 1.03. That's 97%. The fatigue on 97% is not there when you say 1.03. So my guess is that's probably why they did that.
We can always compute as a percentage, and when you finally represent, you can put right?
Yeah. I think you're like 20 years too late right now, Sammy, on that one. So we can have this discussion on what's the right thing to do. uh, I guess the question is, uh, I wanted. I mean, Sami, I had this with you, right?
Right.
Sorry, I didn't go. Keep going. I didn't mean to interrupt.
No, I think that's the main thing we want to kind of conclude on the what is the direction we want to take, because we want to write the white paper based on all the presentations, right? And we want to make sure that we are using the right things before we publish it out, right?
Right. So,
And I want to create some examples based on the formula. Right?
So, Sami, I sent this to you, but let me share it with. Oh, I forgot. This is not link. No, I think. Come on, share. Is it showing up? Yes, it is. Okay.
Yes,
So,
it's coming up.
yeah. So, essentially, I mean, leave your debate on why did they do it as a inverse of an efficiency.
Right.
That's just the way it is, right? But to me, essentially, it is trying to identify the non-IT power. And traditionally, the non-IT power was this data center cooling and data center power infrastructure, right? Now, if you look at like indoor cooling, coolant distribution units, immersion cooling, a lot of these trends, essentially what's happening is, or if you look at 48-volt bus bars and so on, what's happening is what used to be sitting in this purple box is slowly encroaching its way into the green box. Of course, your PUE gets improved, right? Because whatever was my tax became your tax, and you're sitting in the denominator, right? So,
Right.
so we need to make sure. So before you jump to IUE, we need to make sure that in PUE, how this all gets measured, like how cooling and power is handled as new technologies emerge, right? So how do you handle the right-hand side itself is a problem in my mind. Right. So, by the way, I'm not blaming the reason why PUs are getting better is not strictly because there is gaming going on, right? That's not there is genuinely, like when you go to immersion cooling, uh, the pumps for the CDUs are way more efficient than putting a fan in every server. So that's why. So there is genuine improvement here. So I don't want to malign them completely, but there is a little bit of this going on where things that used to sit in the purple have kind of shifted to the green. And how do you do PUV in a modern uh, liquid cooling environment, or even in terms of air cooling, if you're going to do indoor cooling or air door heat exchanger or any of those things, is something that we need to have good guidance on in the document that you write. Okay, so I just want to start there before we jump to IUE, because right, I mean, IUE is not insulated from this. IUE has the same issues, right? Except that it's a new metric, so nobody's using it, so we can there is no gaming going on.
Yeah.
Are you guys with me? Yeah.
Yeah.
Okay.
The even the question on PUE is right. It's you're measuring at a data center entrance, right? But what happens outside, that is up to the systems. How you going to design it?
Yeah, I mean, no, we can always go in and say, look what I've done here, right? I took the IT hardware power, and the green box here is all strictly is useful IT power. So really that should be the denominator. And that clarity can come from OCP is all I'm saying.
Yeah, right.
Right. And
Right.
so the thing is that in 2006, when the people wrote PUE, they never envisioned a world where this would happen on the right-hand side picture would happen.
Correct.
Right. So I mean, even us in manageability, I mean, Jeff wrote this document on liquid cooling. I mean, when we wrote Redfish, we never thought that we are going to be sitting in a world where the cooling is going to be done this way. So we had to go create something called thermal equipment to make this whole thing work out.
Right. So, do we want to put a kind of what is the assumptions on PUE, and
Yep.
that might
So
help drive some conversation
right.
there?
So maybe we need a draft of white paper and essentially call out these things. And this is where I think OCP has generally excelled in not in defining new specs, but in essentially taking an existing spec and tightening it through profiles.
Right.
So if you get the gist of this picture into a profile, then you have kind of improved the way PUE gets used. Okay, so now let's go to IUE since you want to talk about IUE. So IUE so assumes that the PUE problem is solved and essentially says, if I take a look at the IT hardware, is IT hardware basically then breaking into at the IT level, computing power, IT power, and cooling. So this IT power would be things like power supply. This IT cooling would be things like fans, right? So those are, I mean, today they're all counted as IT, but they're not really. If computational load is the only computational load, and even in that computational power, even in that power, the real power is after you take away the idle losses, right? And what's left over at that point is really the true computational power. And that computational power has to be measured at a certain load. I don't know what that load number is, but you have to measure it at that load. And I think I proposed 50% last time because that's kind of the 40 to 60 seems to be the data center average. So I was picking the midpoint there. So the idle losses. So in a heterogeneous system, what does it mean to say idle? What is an idle, right? Idle for a server system is anything less than 10%. If your CPU utilization is pegged at less than 10%, it's considered idle. If you're thinking accelerators and GPUs and so on, if you're below less than or equal to 3%, you're considered to be sitting at idle. Again, these are numbers that we need to pick. We need to have a debate on whether they are the right numbers, but I'm just saying that's the conventional view of idle. And then on the basis of that, you can come up with a metric. And again, here I have no religion on whether it should be follow the IUE PUE follows the IUE and it's a number, or if you want to invert it and turn it into a ratio, which when it becomes more of an efficiency. Right. In fact, I would prefer it to be efficiency because right now I have a divide by zero problem, and that will go away. Yeah. Right? Because
yeah, if you say basically when you say if it is even 1%, 2% doesn't matter, right?
Yeah, I mean, think about. I mean, I thought about it, Sami, right? So I think about that's why I worked around it by saying it's not defined, but maybe it's easier to define it as a ratio than instead of divide by zero, you just get the numerator that's zero. So if you think about it, so right now I'm trying to comprehend like a standard server. Hey, your power supply, that's what 8 to 10% losses right there as you go through the power supply and the DC to DC converting logic. And then if you have fans, another 10% loss through the fans. All of that is what I'm accounting for. But I can see a world where you have no fans because you're in an immersion, let's say. Let's say you're in a bus bar design, right? And you're supplying the DC walls. So maybe your loss is like 1%. So now you're in a place where there is hardly any losses if you think about it at an individual blade that immersed into a tank level. So then if you have I mean, again, thank God that there is no such thing as, no silicon with no idle losses, right? Idle losses will never be zero. But if you measure at idle at that point, then you do have, if your load basically is at idle load, then you do have run the risk of coming up with a zero in the denominator, which is ugly. So we can flip it here if you want it. But I'm fine with it as long as we are defining it, so we can define it however we.
Okay, so we can go with the efficiency as a percentage. if you want to say represent as a kind of PUE model, we can say 1 by whatever the efficiency, right?
Yeah, see, but we so 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 the avoiding the divide by zero is only a mathematical elegance. You still have to worry about, you still have to say, hey, IUE at idle is not defined because uh, IUE at idle as zero, does it mean it's very bad? No, it's not. It just right, because other places it'll be as a percentage it'll be like 80-90% efficient. All of a sudden you come to idle, it'll go to drop to zero. But that's not your intent, right? Your intent is you want to minimize the number of, you want the idle losses to go to zero. But we all know that's a longer road for the idle losses to go down to zero.
So I'm a little confused more. Like, are you saying we should define ideal as a maybe
No.
not zero?
No, I'm saying I'm fine with your proposal of inverting this and making it an efficiency ratio. All I'm saying is that even after you make it an efficiency ratio,
right,
you cannot just leave the, if IUE efficiency ratio is being measured at idle, you still have to say this is not defined.
okay.
Zero is not a good number either.
Right.
It's better than
Zero,
infinity, but it's not a good number.
Right. Now, I think the reason I was trying to go there is for system level, right? Yeah, data center level is different from system level.
Yeah,
system.
You just
right.
aggregate this, right? You just aggregate this over a bunch of stuff, right? One of the things is, one of the reasons I drew the picture. I mean, I know this is like a cartoon, but I drew it this way is because this green box could be anything. When we started out, we were thinking server, like a traditional rack-mounted server, but it could be an entire tank, like in an immersion architecture, or it could be an entire rack because you have a radar hex. So because you can't play the same game that IUE we accuse PUE is playing, right? And say, oh, I punted everything that was an issue out, and now look at me, my IUE is 1 or near 1, right? So we can do that. So that's the thing. So now, to me, all of this I think are manageable. To me, the hard problem is one of the things that PUE actually, by the way, to their credit, they actually did it too. PUE is also defined at load, except that nobody says goes through that. If you read the Green paper on PUE, they talk about load. When you say load, what does load mean in like a rack full of servers is a hard thing to figure out, and that's where we need to spend our time on. Yes.
Sorry, Mohan, one question. You were mentioning, sorry, I joined in the middle of, while you were describing something, but you were mentioning that we want to say IUE at idle is not defined. Why are we saying that is not defined? Like, why won't that just be, active server power is 0. Total computational power is not.
Yeah. So because of the equation, if you essentially take the total server power and you subtract out the computational power, basically you'll end up with
sorry,
zero.
I said that other way around.
Other way around, yeah.
Yeah, sorry. Yeah, I said that other way
I have
around.
a typo
So
here. I have a typo. Yeah. I should have put active in there. So it'll end up being 0 in the denominator. That's why I was saying not defined.
No, but after you actually flip the equation, after that, why do we still want to say?
Because 0 as your efficiency, it's not at 0% efficiency at that point, right? It's just an undefined efficiency. All other point there is an efficiency that's defined for you. At idle itself, say like you could be at some very good efficiency number, and then just because you're measuring at idle, now you're at 0% efficiency. I mean, 0% efficiency means you're in a pretty bad shape. That's not what we're trying to say.
Oh, I see what you mean. Okay.
So that's what I was trying to tell Sammy. Mathematically you avoided the infinity problem, but you still have to, essentially put in words to say it's not defined, just because we're doing idle losses in there.
Yes,
Okay.
basically it's not
Mhm.
applicable in a way, right? So I'll
Exactly.
just say, yeah.
Exactly.
Yeah. Okay. Okay.
It's a
Like, don't
discontinuity.
read
If you
it in
think
the
of it
same
like a
way.
limits, it's a discontinuity in the limits, which is very ugly.
Okay. Okay. Yeah, that makes sense.
Then if you go to the load, right? If you take multiple systems, we propose load for you can come add them together and divide it, right? Total based on TDP. Is that a good measurement?
Yeah. Yeah. I don't know if I did that. Yeah. So essentially, yeah. So if you, what does it mean to measure something at load, right? So essentially, your number of, again, forgive me, Sammy, I said servers. My pedigree, right? It could be anything, right? Whatever the hardware,
just
hardware,
yeah.
whatever the load is. And then each one has a thermally designed power limit, right? And then divided by the TDP is really your load on the system, right? And the reason I'm picking this, I mean, you can immediately say, well, nobody operates at TDP. Yes, but that's supposed to be the envelope, and you're below that envelope in certain sense, and that ratio is defining your load. And it's very easy to compute that for a given single server, but if you're taking a rack or a tank or whatever, and then also if these systems are heterogeneous, right? Even though I used the word server, I should use something else. That has accelerators and GPUs and you name it, then it's a cumulative number for the load is really what you're looking for. And Sammy, I know what you're going to say. You're going to say, well, I'm going to game this. Let me get ahead of you. Yeah. So I don't know how to get to the next level by then specifying a bit. You can't just pick one low and one high and make it work out, because it's a summation. We have to work on that problem. I haven't gotten there yet. I totally understand. You could do that. Yes.
So then basically, like, if you want to do a data center load, we can say it's the same thing for once you do it at a rack level, you can aggregate the same thing at a data center level, right?
Exactly. Say aggregation is an aggregation. So you could do this at any level, right? So I mean, the mistake I made was calling it server load. I should have just said compute load, and that would have been a better characterization.
I think when I put the thing on OCP, I probably changed some wording there.
Did you? Okay.
Yeah.
Okay. Yeah.
So now,
anyways,
if you go back onto the IUE at a rack level, if you want to calculate, you're calculating at a server, each server. And if you want to do that for a rack level, you have to aggregate the same kind of formula for the rack level, right? You have to harvest the data from individual system and aggregate for each system what is the non-compute and compute. Then you need to aggregate it, right?
Mm-hmm.
So you need to know every single operational IUE in order to create your rack level IUE, right?
No, you can just measure it as an aggregate. Why do you need to know each one?
Because ideal power on each system can vary, right? Even within the rack. Each compute or each node, if you think about it.
it's not too much idle power. How much idle losses do you
Yeah,
have?
right.
Right, you're starting at that offset, and,
Right.
and you know, if you, I don't, I can pull it up if you want, Samir. Right? You know that this is silicon induced, right? This is essentially the static part of any power when it comes to silicon. That part is there whether you're talking a single server or an aggregation of bunch of servers or a heterogeneous set of servers.
Yeah, I think if you go back to previous slide, Mohan.
Yeah.
So the right hand side, we'll be calculating per node. Then we'll be aggregating per node to create a rack level, right? Yes, rack does not even understand these things clearly, right? Unless you aggregate them.
Yeah. So you're saying if I have like some big aggregation like a rack or a data center,
Right.
how do you characterize idle loss?
Correct.
If you know, so we'll have to develop that equation, Sammy. Essentially, what that will look like is you may not know. So I see where you're going. Let me verbalize what I think you're saying, and then let me give you an answer. I think what you worried about is don't make me go to every little component and measure the idle for each of this guy, right? But my point is, if it's a data center, it's got X number of components that are unique and they're repeated multiple times to make the data center or the rack or whatever. If I know each one of those unique components, I know each one of those, their idle power consumption. And so I can easily sum up and get the overall idle power. I'll make. I don't have this. I don't have the slides for you for that today. So I can do it next time. I know what you're asking, but to me it's purely another summation.
Yeah. But summation, I'm wondering whether piece it to build from each node, then I'm aggregating each node to create the.
Sorry. Given that I only know Intel roadmap well, I forgive the parochialness of this. So let's say it's the rack is filled with Ice Lake and Sapphire Rapids system. I know what Ice Lake's idle power is. Like let's say there are 10 Ice Lake and 30 Sapphire Rapids system. I know then I know it's 10 times whatever the idle power of Ice Lake is times 30 times the idle power of the Sapphire Rapids. I'm measuring one socket system.
Right.
So yeah, we can do that. And if you have other components, like let's say there is a GPU, I know what the GPU's idle power is as well.
Right.
So,
Okay.
so it's a matter of summing them together. So I
Right,
don't see it as a hard exercise because every component being different is not a likely scenario in any given data center.
Yeah, I think what we are basically, like we say, this is a rack level, not node level IUE represented by the each node. Then the rack, when it is trying to represent the rack level metrics, it can say like it can sum them and provide this similar thing, right?
Yeah. I mean, it's no different than you doing it for a single server platform.
Right. So in which case, basically, like as a data center operator, they are getting from each rack and they can submit to data center level and say like, hey, this is the number.
Precisely. It's not. I mean, it's a little bit more involved than, PUE, which was more at a more aggregate level. But again, like I said, even PUE has all these components. It's just that nobody uses them. So the question is, when we get there, how are we going to make all of this workable to the point where somebody can measure it and report it? And that's a much more interesting and longer conversation on what tools are we going to provide to make this all possible.
One question on that. So, like, suppose I know there are so many Sapphire Rapid nodes in this particular rack. I can know the idle power of those Sapphire Rapids, but what are we doing about, there are other these other components which are like, there are drives, NIC cards, etc., also contributing to the rack power?
Yeah, so now we are in an interesting discussion that the Shruti, right? So those IO devices traditionally have the ability to be power managed, right? So you could technically go put them into D3 hot or D3 cold, and if you put them in D3 cold, they're supposed to be consuming practically zero power, right? Whether they really do that or not, that's a debate that we can have. But the assumption is they are all capable of being power managed to the point where you can literally remove the power from them and they're still okay. Right? That won't be true for networking for sure, right? Because that will make for a disastrous networking story. But for drives and so on, I can see them literally going to zero and coming back up. And also, we have to look at things that are uh, if in the Pareto that move the needle, right? So CPU power, highest CPU power is like in the 350 watt range. The GPU power right now is around 600 watt range. So they are they are they show up in that Pareto. Whereas if you look at a drive, it's probably like 10, 15 watts. So
Right.
So that's where, unless you're like a storage system, it's not going to.
Right. That's what I was going to ask, because the drives, like if you are having hard drives in there, they are not going to be, put to zero power in the middle.
Exactly.
And then
but,
they also multiply very fast.
Right. If you look at like a storage system, and then you're taking like if you have those bays that have 24 drive nodes. Now 24 times even a small number like 25 watts each is going to be close to 600 watts. Now now you're kind of breaking it. Yeah. So lots of interesting items, right? So the question is going to be, which one do you chase down first, right? And the things to chase down would be processor and GPUs that consume a lot of power, and then the rest of them, I guess, we'll have to go figure out later.
Okay, so are we sort of saying that this particular definition that we lay down for the rack level will only apply to compute systems or compute rack level?
Initially, I'm saying we have to start somewhere, and we should start there, because if you try to comprehend everything, we'll be here till the end of 24.
Yeah, no, that's fine. We can start there, as long as we have that clear that this applies to the compute rack systems.
Yeah, that's at least my proposal, that you start with compute elements in the rack, and then let's assume the rest of them are not impactful when it comes to this, and then we can come back and deal with it later.
So that little bit.
Go ahead.
No, I was just going to say that little bit throws me off when we say the rest of them are not impactful, because we are not saying it applies to compute racks only. We are actually saying all racks, but not.
No, I'm not saying it. They're not impactful. I'm just saying, do they? If you draw a bar chart, I'm just looking at the highest ones on the bar chart and then go from there.
So I do understand it's not.
Good.
No, just last thing. I do understand they are not impactful if we look at, compute rack systems. Then I understand that statement that, okay, these other elements are not impactful.
Yeah, I agree with you. Like if you, that's why I used the example of storage rack. If you have storage rack, then you're looking at a different problem, right? Like I said, you could be, your storage still could be consuming 600 plus watts, depending on what kind of storage nodes your storage drives you're using. So we have to then maybe the one of the next steps, and I can do this, right? I was going to start with compute, but we can talk about storage. We can talk about like an accelerator node where you have 2 head nodes and 8 GPUs, or a bunch of accelerators, or like an OAM based NIC. and look at each one and see what happens with them. Just go through all the entire list of components and characterize them. We can definitely look into that in one of the subsequent calls. And I'm just saying, in terms of Sami finishing up the white paper draft or whatever, Sami, by the end of this year, I don't think you have time to do all of it and get there between now and 31st.
I think my question on is, do we want to say compute or do we want to say maybe keep it server itself? So it can be compute, can be storage, can be anything network or anything, right? That way it's applicable.
Yeah, so maybe even more generic terminology is like an IT element, right? It could be compute, storage, or networking, right? So for example, you can have white box networking type things where they have like a switch element, and then there is a bunch of networking, like processing going on there also, right? And they have these VPN type boxes that are networking boxes, technically speaking. So we definitely let's call it IT element. That way, we're not saying compute or storage or whatever.
But we would be at the IT element level then, not at an entire rack level.
Yeah, I think we need to define what
server
it is.
level.
Yeah, we need to say IT element could be a pure server, or it could be a pure storage node, or it could be a networking node, or it could be a GPU node, whatever it is. So we will have to go through the definitions, and then we need to get into each one's. What does it mean for each of the components to be idle?
Right.
And then also you can pick different configuration, min, max, medium size, etc. So that way you can model it, and then you can drive into the measurement. So that way you can get more insights in a way, right?
Yeah. Let me bring some sample configurations, and then let me bring in the power consumptions, what they would look like, and then what does it mean to be idle for each one of them, and then we can have a discussion on, which would. My only thing was, I don't think we have time to do all of this by end of the year. I'm not saying we shouldn't address them. So I'm just eager to get something across the finish line for 2023.
Sure. Yeah. Okay.
Yeah, we can, as long as we can say this needs additional work, we can call it out, right?
Yeah. So this is one of the debates I had. Maybe Shruti, we should have a chat with Sami, right? So I can see two ways, Sami, right? One is you can do the IUE profile and as a separate white paper. The PUE profile as a separate white paper, because it's essentially tightening an already existing spec. And then the IUE is more of a draft thing where we say, hey, we don't have all the T's crossed and I's dotted, but we'll go work on it in 24. But here is like a 0.1 draft or a 0.3 draft, whatever it is. That will be the clean, but then it's double the work because now you have to write two white papers. The other alternative is to put them in one, but then the content will be somewhat uneven, right? Your PUE content will be a lot more mature than the IUE content.
Yeah.
Let us probably get the content ready. I will try to get another. Anyway, we don't have a meeting next week, and week after next, I can bring the content. Then we can decide whether we want to separate them out or we can keep it in one, right? On PUE side, what we are really trying to say is it is at data center level now. If you want to make it as a rack level and a system level, what is that looks like, right? It's basically assumptions that we want to clarify. Right, Mohan?
Sorry, say it again, Sami.
PUE white paper.
Yeah.
It is basically trying to clarify what are the assumptions that we are making.
Yeah, it's not even it's not even a white paper. It's a profile document. Just like, you can take a look at what Jeff and John had done for manageability on the profiles, the OCP profiles. It needs to look very similar to in terms of structure.
And we don't have PUE profile today, right?
Nope,
Right. Okay.
we don't. We don't.
So we don't need to come up with a new definition. What is it? How do we make the PUE to be operational in a OCP concept systems, right?
No, that's right.
As
If you're
yeah.
OCP compliant,
Right.
what does it mean to say my PUE is X?
Right.
And that's the profile document.
Right. Right.
And then obviously there'll be a lot of debate on it, but I think putting it out is going to cause that debate to happen, which is good.
Yeah, I think if I think back, maybe separating it out gives freedom of we are debating about PUE, what is defined today. We are not altering anything what is defined. How are we operationalizing at a OCP level?
Yep.
And get that buy-in to make sure that this is what it is happening and we can agree on it, right?
Right.
Okay. So then I think that case, yeah, the IUE will be kind of dropped, and PUE you want to really like close that as a kind of this is expectations. Maybe that really needs some lot more reviews so that we can say it's a done white paper, right?
Yeah. So separating it out to me gives you the luxury of making one a white paper and the other a profile.
Okay. For going to profile, then do we really need to have any red piece definitions done on that?
Say again, Sandy?
So if you want to do a PUE profile, how is the number is coming out of data center? Today it's probably what is coming to the if you go back to the picture, right? I think it is measured at a very high level, right? DC cooling and DC power.
Oh, on the PUE, you switch
Right.
topics. Okay, yeah.
So is there any system play involved there? That's what I'm making sense.
Don't know what you mean by that.
Let me share this on back the picture what we put, right? So PUE we are saying it's DC cooling, DC power. There's non-IT. The remaining is IT power, right?
Right.
Yes. In order to get this, do we really asking for a rack level data that need to come out? Or is it in the data center level, it's no play for a node level or a rack level?
Yeah, it's they're just looking at I had it in one of the other ones. It's essentially in how you measure power. Cooling wise, nothing.
Right.
From a power standpoint, it's there are complications on how you do it. Let me see. Give me 1 second. If you have the spec, it's towards the 2/3 of the way down in the PV spec. They have this picture that shows you how power is measured. So power is a little bit more complicated, but nobody tells you how they measure it, so it doesn't matter.
Okay. I'm trying to say like even when we are trying to put a OCP hat here, we want to really say how is that done for an OCP system, or we are really keep under the data center level?
No, you still have to show you remember we had this disconnection on level 1, level 2, level 3.
Right.
We still have to figure out which one.
Okay.
It's in one of my presentations in this forum. So you have to
Yeah.
figure out which one are you going to say. So I mean, again, you can't really mandate. You have to just say, if you're doing level 1, you do this. If you're doing level 2, you do this, and so on. Because some of this, it's a capabilities thing. So if I have a data center with 100 servers, you're not going to really ask me to measure it, do the level 3. I don't have the ability to do level 3.
Correct. I think the question I'm kind of want to ask is there anything that we have to define at a node level and a rack level that is not currently existing all Redfish profile?
You don't. No. In Redfish profile.
Right. At the end, I'm trying to say, how do we operationalize, right?
This is just power reporting. I wasn't thinking. I don't know if there is a Redfish component to this. It's mostly tightening out what they're saying. In fact, even the terminology is actually defined in the spec. It just nobody uses it. Hold on, Sammy.
Hey, Mohan, this I don't know if you is that picture editable? I'm looking at the slide and realizing that it would be a lot clearer, I think, just for this slide, which not what Sammy was asking, or sorry, not what Sammy was asking, but the after side here on the right side with the non-IT power, IT power. If you shifted the IT power up to make it, to show that like my non-IT power has actually decreased and the IT power totals have increased. That's what really
that'll show the. Yeah, I see what you mean. Yes, yeah, it's.
Move this one up. Yeah. Move it up.
No, not that one.
No, the other one. I see what I mean.
Make the green boxes larger on both of the on the two right-hand side green boxes. If you made both of those larger, and shrunk the non-IT power, and maybe if the rest of those, that the DC cooling, DC power, maybe if that was the same size as the non-IT power, maybe that helps too. But to me, it was the most important part is you got to make the ratio of non-IT power to IT power in the before and after case. They look the same, and that's not what the issue that we're conveying here.
Yeah, exactly.
So shrink. So raise that one up 10%, and then lower the shrink that non-ET power a bit. There you go. Just something like that.
Yeah, exactly. I think that's a good point. That's a good point, Jeff. That's what it was meant to convey. But
right. No, not that one.
Leave this one. Okay.
Yeah. This one. Leave the right hand side.
Okay.
Yeah, leave the left alone.
Yeah.
Visually, it conveys the same information.
Right. Okay. Now you're trying to say this is what we are trying to represent here.
Right. That's the issue with PUE is that, look, I've moved. Exactly. So I've moved, IT power. I've moved the DC. I moved the power, the cooling, and the conversion losses into the IT segment. So even though I haven't actually changed actual efficiency, my PUE looks better.
Exactly.
Right.
Okay. Visually showing the problem. I get it.
We can adjust the others to match this.
I'm sorry. I was just, as you were talking, I kind of realized that's why I couldn't figure. That's why this picture didn't say the information to me. So that was the.
Okay. And in fact, we can put this on top if you want to make it.
Yeah, you could do that. I mean, I would think that actually, and just not to do all slideware here, but I would probably make that DC cooling and DC power. I'd probably make those boxes the same.
Same size.
As non-IT power. Yeah. Anyway.
Yeah, there is a lot of Sammy. It's in my other laptop, so 5 minutes, I don't want to struggle bringing it up and connecting from the other computer. We'll do it next time, but there is a lot of subscripts that were defined as part of PUE, to the credit of whoever wrote the spec, right? It's just that nobody follows it. So yeah, I think what you're saying is that, hey, which do we need to go specify what subscripts are needed? Absolutely. That's the whole point of writing a profile. We need to say which ones are, or we are going to say needed from an OCP standpoint.
Yeah, and from the profile standpoint, that could we may be able to convey that in profiles with effectively with like equipment types. To
There
say
you
like,
go.
if you're if you're a PDU or if you're a CDU, then then you need to provide these things. Or if you're a
yeah.
you're a rack CDU, maybe you need to provide this, but if you're a building CDU, a facility one, then maybe you don't. Yeah, those kind of things I think we can do.
Exactly. That's why just I was referring to the one that you and John did at the manageability, because you guys got around this by saying if implemented.
Right.
Okay. We can point to that and say like, this is what we are expecting, and if it is implemented, you will get it.
Yeah, exactly. Okay. So that way you allow data centers with varying capabilities,
right,
to exist and report.
Okay. So then I think we should really like say here we have this definition. So how do you combine L1, L2, and L3 in OCP profiles? If you do those aggregations, then you'll get the PUE.
Right. It's a multi-subscript thing.
Right.
So again, Sammy, we can, if you want to pick PUE as the topic for next meeting, which is I think in 2 weeks,
right,
we can just get into the depths of PUE and talk about PUE, and then so like when we say power,
right,
we never discuss whether it's what is power, right? I mean, is it dynamic power, mean power, what is, so there is a lot of caveats there too. So we can have a full discussion just on the PUE topic next time, and then maybe after that we can come back to IUE and talk about it.
Yeah, I think that probably makes a total sense. Let me also get the white paper started, that we can have what are the open definitions that we need to review and tighten it up, right?
Yep.
Yeah.
Sounds good.
Okay. Yeah, 2 more minutes. Any other comments, questions before we close today?
Just a question. So at some point, you're going to define the measurement techniques via software stack or API. That way you can automatically measure these in a way.
Yeah. So that is the one, the telemetry or group trying to get those definitions right. We are trying to define the matrices, and I think as part of the telemetry, we're going to get those data.
Sounds good. Yeah, we talked about it. Yeah,
right,
sounds good. Yeah.
Okay. If no other comments, have a good Thanksgiving, and we'll see you, the team, in 2 weeks.
Okay. Happy Thanksgiving, everyone.
Happy Thanksgiving, everyone. Thank you. Bye.
Happy Thanksgiving.
Bye.